Well, hi there. This is Craig Hane, and my students call me Dr. Dell, as you know. And this is going to be a video that's actually a supplement to the video that's entitled Math Proves That God Exists. Now, if you already know a lot of science, then you may not want to watch this video. You may want to go straight ahead and just watch the Math Proves God Exists video. This is on this PDF, and it's about 4 pages of a PDF where I talk about that. But if you're not really that up on science, you may want to watch this video first, because in this video, I want to really talk about sort of a brief history of science. I want to give you some perspective. I call it sapient perspective. We're sapiens, human beings, as it were. And I want to give you a little bit of an idea of what this is all about. So this is the video that is a supplement to the Man Exists God. First of all, historically, all science theories have explained a very limited number of phenomena, and they've been inadequate to explain others. And that's true of all science theories, including the most modern ones we have today. And any scientist, I believe, would agree with this. But let's talk about how we got to where we are today and where we are at this point in time. In the early 1600s, Galileo really kind of is the one that started modern science. He's the one that said, look, you have to develop a mathematics model for whatever it is you're trying to explain and understand, and you have to do experiments that verify that that model, it gives you correct information, and any observations you make, whether they're experiments or observations, your model has to be consistent with that. Otherwise, it's not a good theory. And that was very much in conflict with what human beings had thought up until that point in time, starting way back with all the earlier civilizations, the Greeks, for example, and all that. And he was able, for example, he was the first one to use a telescope to see the moons around Jupiter and, hey, wait a minute, the moon is going around the Earth's going around the sun, the so-called Copernican revolution. It was not appreciated by the leaders of the day, if you want to call them scientists, whatever you want to call them. In fact, he was prosecuted for this, persecuted, and put in prison and house arrest for the last part of his life. But it wasn't too long after that, later in the 1600s, that Isaac Newton in England came up with the first, what we consider to be modern science theory. And he created it in the mid to late 1600s. And what he did is he had a mathematical model for what we call the laws of motion, and he had another mathematical model for what we call the theory of gravity. And he put these together and was able to explain how the planets moved and everything like that, and all sorts of things. And he published it in a great book called Principia Mathematica, considered the greatest science book of all time. And one of the reasons Newton could do this, by the way, is he had discovered a modern tool called calculus. And the fundamental theorem of calculus, undoubtedly the most important theorem in the history of mathematics, is what let him do what he did. It's phenomenal. And of course, I explain all that in my math training. If you take my math training, that's all explained. And today it's very easy to understand. And in fact, it's easy to use today because of modern tools. Now, Newton's theory was wonderful for explaining all sorts of things, but he knew very little about electricity and magnetism. His theory didn't really address that at all. And so nothing was done about it. He did talk about light, for example, and he had some ideas about light, which it turned out some were right and some were wrong. He didn't really have a theory of light that was good, and he knew that and kind of admitted that. And then in the 1800s, and by the way, the Industrial Revolution was started because of what Newton did, because this laws of motion and gravity and all that was what let us start understanding physical phenomena, the things that we do. And it really was the launching of the Industrial Revolution. But the early Industrial Revolution was all about mechanical stuff, and hydraulics and pneumatics and mechanical stuff, had nothing to do with electricity and magnetism. And a great experimentalist by the name of Faraday in England did some experiments, and he saw, oh, electricity and magnetism are somehow related. somehow they involve the same thing. And he came up with Faraday's laws. He didn't understand, he had no model for it, just this is the experiments. Well, then Clerk Maxwell, the great theoretical physicist from Scotland, came up with a mathematics model that explained electricity and magnetism and explained the results of Faraday's experiments, and went beyond that and made some predictions about light, about the speed of light. And that then, well, I'll tell you about that in a second. Now, I will tell you, Newton, in the 1600s and even in the 1700s, nobody had any idea about how this worked. They couldn't have predicted anything that came later. Benjamin Franklin was beginning to understand electricity and batteries, but he didn't have any concept of what Faraday ran and learned in the 1800s. Newton certainly had no concept. So all of our ancestors were totally ignorant of this at this point in time. Now, they thought they knew a lot more about the way the world works than their ancestors, but nowhere near what we know today. Well, then Einstein came along, and the first thing he did is he overthrew Newton's theory in 1905 with what's called the special relativity theory. And if you know about that, you know what I'm talking about. But it really changed the concept of space and time. And it turns out time's not the same for everyone. In fact, your time will change if you go up on a mountain, it changes. If you get in an airplane, it changes. Very slightly, but it changes measurably. And we can prove it. In fact, the faster you travel, the slower time's going to be. And in fact, the less gravity, the faster time will be. And in fact, if you have a photon of light, a beam of light, which is full of what they call photons, as a photon travels along, time stands still. There is no time. A photon that started 1 billion years ago to the photon, its clock hasn't changed. It's the same time as it was 1 billion years ago. Now, all of this contradicts Newton. Newton would have had a lot of trouble with this if he'd have known about it. Oh, something popped up here. I made a mistake. Let me get rid of that. Sorry about that. That's me, here playing with technology. Okay. The Newton would have had no idea about this. Now in ordinary speeds and situations, Newton's theory and Einstein's theory are very similar. So we still use Newton theory for ordinary engineering stuff we do. But we have to use Einstein's theory for certain things. For example, there would be no GPS today, and we all use GPS on our phones, right? Our cell phones have it in it, and it's how we get around. Well, GPS had to have two corrections in it, one for special relativity theory and one for general relativity. And if they didn't know about those two theories, there'd be no GPS today. And so Einstein's theories were critical for that. But then after Einstein, which was the early, like I said, 1915 was his general relativity theory. Then later on, in the 1920s, scientists came up with something called quantum theory. And they had equations that described how electrons and photons and all of that behaved, but it was very non-intuitive. In fact, it was hard to even imagine and believe it. And it became what's known quantum electrodynamics. And this turns out that QED, quantum electrodynamics, explains everything that goes on today in the ordinary world. All chemistry, everything that happened with light, lasers, all of that explained by QED, chemistry and all of that. Well, it was very difficult to calculate with it, though. The equations were so hard to deal with. And in the early 1940s, 3 physicists came up with a way of finally calculating with it, Richard Feynman being perhaps the most well-known and famous of them. There were 3 of them. And we started using then QED to do all sorts of things. And so today we have much of our modern technology is based on quantum electrodynamics. And by the way, it's the most accurate theory in the history of science. It predicts things down to just an immense amount of accuracy. Then sometime after that, they applied quantum theory to the nuclear idea, and they came up with quantum electrodynamics, what's called the Standard Model. And that's then what finally led to a lot of what we understand today about the nucleus and all of that, how that works. And of course, that all led to things like the atomic bomb and all that. Now, here's a problem scientists have you'll be interested in knowing today. I'm making this video in late, almost 2021. Relativity theory and quantum theory contradict each other. In special circumstances, they contradict each other. And everybody knows that. This is not controversial. Any scientist will tell you that. If they don't tell you that, they're ignorant or lying. They contradict each other. Everybody knows it. In fact, it's a horrible situation, and scientists are grappling with it. They're trying to come up with a unified theory, something more basic that will unify these two contradictory theories. One of them is called string theory, but they've been working on that for several decades, and it hasn't worked yet, hasn't done it yet. They haven't achieved it yet. It's a problem. Not only that, they've made discoveries that these theories don't deal with and don't explain. Dark matter is one of them, dark energy is the other. Won't get into that now. I'll just tell you today, science today knows that our theories are inadequate. They know that there's things we can't understand, that they acknowledge. Now, I believe, and I'll tell you why in a minute, it isn't just because of me, it's because of another great scientist I'm going to tell you about, but there's a fatal flaw in the current science models. And it all started with Einstein. Einstein recognized that anything that's physical cannot travel at the speed of light. It's always going to be slower than the speed of light, because as it travels faster and faster, its mass gets greater and greater, and it would become infinite at the speed of light. So it can't go to the faster speed. So he assumed there was nothing else except the physical stuff could not travel faster than the speed of light. Now, quantum theory had a problem with that, because there were things about quantum theory that's very non-intuitive, and some people thought, well, there is something that's faster than the speed of light, but nobody wanted to admit it or acknowledge it. De Broglie's an example of that. And so basically, quantum theory was the model set up for quantum theory did not assume anything traveled faster than the speed of light. And I think that was their big mistake. So here's a point. Suppose there is what I'll call non-physical stuff, something that exists, but it travels faster than the speed of light. Well, it's not physical stuff we know about. It's not, by the way, the things we know about the physical stuff, the scientists today in 2021 say that that only composes 5% of the universe that we observe. 5%. A bigger percentage is what they call dark matter. They have no idea what it is. And another big percentage is dark energy. They have no idea what that is. So it's really today, science is in a state of mass ignorance, and they know that. Well, I'm going to call the non-physical stuff supraphysical. I like the word super. That means beyond. So this supraphysical stuff, which is as real as physical stuff, but it's just not what we think of as physical stuff, this would obey a very different math model. Einstein's model was radically different from Newton's. Well, the supraphysical model is different from the current standard models we have. Well, there's a scientist today that I consider him the modern Galileo. His name is William Tiller, Dr. William Tiller. He's about 90 years old today in 2021. He's been doing science all of his life. He's a mainstream scientist. He worked at Stanford University he was chairman of the department for a while, the material science department. He worked there, he was a professor many years, but he also studied the superphysical stuff, because he thought it might exist, and he studied it, and he found out it does exist. Now, he's come up with a model for it that's very interesting. It's a math model. It's a good, solid, the math is solid. Whether the model is an adequate model is another matter. But it's in the superphysical part of the universe, everything's based on what's called frequencies. You don't have time domain stuff. You have frequency domain, and you have to be a pretty sophisticated mathematician to understand it. This is not high school math now. This is going to probably take you, if you study my math and get up through calculus and differential equations when you're 16 or 17, which you can do today, and if you're interested in the math, you could probably get up to this in a matter of another couple of years. So you could, by the time you're in your late teens, you could know that if you're interested in it. The time and frequency domains are sort of, in a sense, reciprocal of each other. Like I said, it's a sophisticated model by high school standards for sure. Tiller was a very respected mainstream scientist. He published hundreds of papers in mainstream science. Then he published other things. Now you go to his website, tillerfoundation.org. And what you're going to have there is 4 books that explain this. And that's where I learned about it. He started publishing these books about 20 years ago, and a lot of white papers. The books aren't very expensive. You can study the books or study the white papers if you want to understand it. So if you really want to know where we are at the frontier of science today, in my view, you need to study Tiller. In fact, to me, that's almost more important than studying quantum theory and relativity, although you'll have to understand them to some degree too, to understand Tiller. So it's not a trivial thing to do, but it's quite doable. And I'm just going to give you one little quick last example of science and how science can go so wrong. One of the greatest scientists alive at the end of the 1800s, the 19th century, was a guy named Lord Kelvin. Great scientist. He had a model that, based on everything they knew at that point in time, Newton and all of that, that described how the Earth was. And based on this model, he could calculate that the Earth was between 20 and 100 million years old. Now, other scientists, like archaeologists and geologists, I said, wait a minute, it's a lot older than that. We've got other science models that prove it's older. He said, no. My model's the right model. And since my model is the best model there is, your models are no good and you're wrong. Well, something was lacking in his model. And by the way, it's because this thing was lacking, his model was wrong. And what do you think was lacking in Lord Kelvin's model? That he couldn't make a proper prediction. Because the facts are, we know today the Earth is, what is it? 5 billion years old, something like that. 4 or 5 billion years. A billion is 1,000 million. Well, I'll tell you what was lacking in Lord Kelvin's model. He didn't know about it because scientists hadn't discovered it yet. They didn't understand it. It's called radioactivity. Radioactivity changed everything. Nobody at Lord Kelvin, they know about radioactivity. They couldn't even conceive of the atomic bomb or the hydrogen bomb, fusion and fission. Couldn't even conceive of that. Had no concept how that would be. Absolutely beyond anybody's imagination. And we're talking a little over 100 years ago. In fact, I'm not sure when they finally realized, it was less than 100 years ago, they realized that, gee, there might be something that is called radioactivity with uranium could cause an atomic bomb. And they began to work on it. In fact, I was about 7 years old when they blew up the first atomic bomb here in the United States as a test. And then, of course, not long after that, they dropped 2 of them on Japan at the end of World War II. And so that's not, it's 2021, I'm 82 years old. Not that long ago. I mean, it seemed like a long time to you. You're a young man, you're a young person, young woman, young man. But 82 years isn't very long, and in the scheme of things, it's very short. So this is what science is about. Now, I believe that, as I told you, that Tiller has got a much, much better model. And by the way, it doesn't contradict relativity and quantum theory. I mean, those are fine. They're included in his model. But for example, maybe dark matter, which they can't find anything physical. They've been looking and it got some ideas. In fact, Neil, one of the great physicists, said, we shouldn't even call it dark matter. We should call it dark gravity. There's gravity out there that we don't understand where it comes from. We think it comes from matter. Well, maybe it doesn't. Maybe it comes from the non-physical universe, because there is a connection, by the way, between the physical and the non-physical. And in fact, as I'm going to tell you in the other video that you're going to watch about math, in my view, proves that God does exist. I'll tell you about that and why that is. So you'll want to watch that other video. So this was sort of a very quick overview of the history of science. Now, if you want to learn about quantum theory, read Richard Feynman's great book called QED, Quantum Electrodynamics, QED. You'll understand quantum theory. There's other books that there's YouTube videos and things that will begin to have you understand relativity theory. Special relativity theory, not too hard to understand. General relativity theory is pretty deep mathematics, pretty hard to understand. But anyway, that's what this video was about. I wanted to give you the quick overview of science. And now you're ready, I believe, if you kind of sort of understand this, to better understand my other video now on why I believe that math proves God exists. In fact, I'm going to give you two proofs, not one. Okay, no extra charge, two proofs. So this is Craig Hane or Dr. Dale, and I thank you very much for watching this video. I think it was great that you did, and I hope this helped you. And now, if you haven't watched it yet, watch the other video and enjoy yourself. I'll see you on some other videos sometime.